Okay, maybe we can do something with this 21 cage, because we know these numbers add to 12. Now, that means they're either 5 and 7 or 4 and 8. But if they were 5 and 7, we couldn't fill this 13 cage, could we? Because we know this 13 cage is either 5 and 8 or 6 and 7. So if this is 5 and 7, we can't fill it. No, I think that's right. So this must be 4 and 8, I think, which means this is 6 and 7. That must be 8 and 5. Let's put that in. 5, that can't be a 5. Okay, maybe does that help us at all? I'm not sure, maybe. Yes, it has. Look, now where can we place a 5 in this 3x3 block? I've seen this trick in these Daily Killer Sudoku puzzles before. We have a 5 here and 5's penciled here, so we know that there are no 5's in these squares. But look at this 10 cage. They can't obviously there can't be a 5 in this cage, because if there's a 5 in this cage, there'll be 2 5's. There's no 5's here either. So the 5's can only go here, which means this must be a 5 and 8 combination. Now that might help us. 5, maybe not. Well, I suppose we can note that this has to be 5 and 7. So with this 5 here, this must be the 5, this must be the 7. 5, 5, 5. 7, 7. Oh, this 7 here resolves this way, so that must be a 6 here. 6, 6. This can't take a 6, so there's a 6 in one of those two squares. And there's a 6 in one of these two squares, just by simple Sudoku rules. What numbers have we got in here then? We've got to place the numbers 1, 3, 5 and 9. This obviously can't take a 1. 3, 5 and 9 in there, which means that this square is a 3, 9 or a 7. Now are any of these eliminated? Well, I'm wondering about this 23 cage. Let's just think about this for a moment. If this is 23, we know the other 4 cells in this 3x3 block must add to 22. So 23, so that would make this cell, and this cell have to add up to 17. Okay, so if this is a 3, these two cells would have to add up to 14. But that's impossible because we already have a 6 in the cage and we already have a 5 in the cage. So the only two ways of making 14 in 2 cells are 6 and 8 and 5 and 9. So this is not a 3. Therefore this is not a 9. Let's just carry on with that logic just in case it can take us a step further. So 2, 17. So if this was a 9, these two cells would have to sum to 8 without being 2 and 6, without being 3 and 5, so they'd have to be 1 and 7. But this cell can't be a 1 or a 7. There's a 1 here and there's a 7 here. So this isn't a 9 either, this is a 7. And that must be a 5. And that's lovely, that's going to give us those two numbers. Means there's a 1 in one of those two squares, look. 7 here. Oh, we've got 1, 5 here, so actually we can, that must be this way round. 5, this can't take a 1. What were the other numbers I needed to put in here? 3 and 9, I think. Let's just write those in. Okay. So this 23 cage now can't take a 5 or a 7. Let's just look at the ways that we can do this. And this combinations box here. So can't be that one, can't be that one, that one, that one. And quite a lot of these are getting ruled out. It must contain a 6, we know that, so it can't be that one. In fact, there are only two ways this 23 cage can work. 1, 3, 4, 6 and 9, and 2, 3, 4, 6 and 8. Okay. There's 4, 5 here, that can't be a 4. So, that just in case it helps us. I don't think it's going to. There's got to be an 8 in one of these two cages. So if so what are the options here then? If the 8 is in this 23 cage, then the other numbers are going to have to be so this would have to be the 8, this would have to be 2, 6. That's absolutely forced. Which would mean we'd still need to place the numbers 1 and 9 somehow in these two cells. Now this can't be a 1, so this would have to be a 9 and this would have to be a 1. That's one possibility. The other way round would have this as the 8, and then we have to put 1, 3, 4, 6 and 9 in here. So this then 1, 3, 4. So then we couldn't have a 2 in this box, so this would have to be the 2, because this would be the 8. So in fact we've managed to narrow that down quite a lot there. So if this is 2, 9, okay, well look, this two cage is bigger than this 2 cage, so this can't be 2, 3, because if it is, then this cage would contain a 9, and that would make this cage bigger than this cage. So this cage does contain a 9, which means this cell cannot be a 9. Wow. Let's just take a look at this block here. With 10 plus 19 is 29. These three cells therefore have to sum to 16. And we have a 5 in there already, so it's going to be an 11 in addition to what we already have. Now, in order that that's true, what 11s are left? We've got a 2, 9 combination. Well, obviously this cannot be a 9, so that would have to be a 2 in that instance. Or a 4, 7 combination. So one option would be that way round. The other option would be that this would be a 4 or a 7. This would be a 4 or a 7. But if this was a 7, this would be a 1, 3, which would mean the puzzle was not unique, because we'd have the same arrangements of 1s and 3s in these two positions here, like this. So this is not a 7. Right, that's helpful. Well, there could be a 7 here, this 7 here removes that possibility. So this is a 2 or a 4, which means, and this cell is its sort of counterpart. Whatever this cell is equal to, this cell must be equal to, because you can see it's sort of rebalancing itself. And let me just show you what I mean. We know these three add up to 11, so if this is a 2, these will be 9, and this will have to be a 2 as well. So this is a 2 or a 4. And okay, so if this contains a 2 or a 4, and doesn't contain a 5 or an 8, so it can't be that one, it can't be that one, so it must contain a 6. So there must be a 6 in one of those two cells, which means this cell is a 6. That's nice. Okay. So if this is a 2, this will have to be 3, 6, and if this is a 4, this will have to be 1, 6. So this is the total arrangement, I think, that we can get to in these squares. Now, just coming back to this 23 cage and thinking about it again. if this is an 8, if this is an 8, puzzle breaks. Because if this is an 8, that means we're in this version, 2, 3, 4, 6, 8, we need to place in these cells. So this would have to be 3 and 4, this would have to be a 2. But this would be a 1, because this was the 8. So this is a 1 and this is a 2, and now we cannot fill this and make 11. It's impossible. What we'd be left with is 3, 4 and 6 in these squares, which add up to 13. So this is not an 8. I think it's fair to say this is not an 8, therefore this is an 8. Therefore these cells, and we know these 4 cells here have to sum to 22, so this is a 2 here. We know this can't be 2 and 3 because of the reasons I discussed earlier, so this is a 9. Therefore this is a 1 and a 3. Now that must be helpful. 7. So what do I need to put in here? I need to put a 9 in here somewhere, which now must be in this central cell of the grid, which that's going to resolve this 9, 4 combination over here, look. This can no longer be a 4, therefore this must be a 4. And this has to be a 1 or a 3, which gives us a 1, 3, 6 triple along row 4, which means this must be a 7, which resolves that. That must be this way round then. This doesn't take a 3, therefore this must be a 4, therefore this must be a 4. And is this working? Yes, I think it is working. Good. Okay, not an easy puzzle. We can now resolve the 1 and 3 here. And now how can we make this add up to 10 only with a 3 and a 7? That only works that way round. We know these 2 cells add to 11. 2 and 9 is the only possibility, and it's still working. Look, that's a 2 and a 9 then. This doesn't contain a 9, which means this is 5, 7, 4, which looks like it does work. That's good. This must be 3 and 8, which has to be this way round. Therefore no 8s over there. This is an 8 in this cell, and this must be a 4, which means we have a 9 in one of these 2 positions, and 2, 4 here, which resolves itself like that. So I think we've done the puzzle now. We'll just finish it off just for the sake of good order. So it is an absolute beast. This 5 here fixes this way round. 1, 2 and 9. It's got to be a 2 or a 9. Oops. What's we looking for here then? 2, 8 and 9. So this must be an 8. This is 2 or 9, which must be a 9. This is therefore a 2. That means this is a 2. 5, 8 resolves itself up here, look, that's good. This must be a 9. This must be a 6. Oops. And this must be a, that's, whoopsie, that's, oh dear, that's a 1. And this is a 3. And hopefully now that's that way round, and this is going to be, and there we go. So it says I took 0 seconds. You've seen it. I took about 29 minutes explaining it as I went. I hope it was okay to follow. I realised that these puzzles are not easy, and I probably didn't do the best job ever of explaining it. But this is a 10 out of 10 difficulty. I don't think you find too many puzzles harder than this anywhere. They're wonderful challenges. I really recommend the site, I have to say. And we'll be back soon with another edition of Cracking the Cryptic, perhaps just doing a normal Sudoku next time. Thanks for watching.